So we have to dig out all the long sleeve shirts, but it's still lovely weather at the moment. Thanks for the opportunity to present. I'm going to try and keep it short and sweet, because normally I talk too much. The topic and the passion of interest here is to put as much biochar into construction, specifically roads, road bases, hard stand areas, factory hard stand areas, access roads to remote and rural areas. And lately we also had a lot of success doing or putting up to 15% biochar by mass of a road product into heavy duty mining haul roads. Our vision, purpose, values, the first mission or the vision we had was to scale the production of biochar from waste. The industry has been growing and so dependent on agricultural char, soil carbon chars, animal feedstock chars, but that normally comes at a price that many farmers can't afford. So we took a step back and we said, well, how can we scale this production? And the end game for us, or actually the starting game for us, was to create the small percentages that is currently put into concrete systems with quite success, but it's quite low volumes or low percentage mass that go into these concrete structures. So we managed then to, together with a proprietary and anionic high pH anionic emulsion system, we managed to be able to even make contaminated biochars inert. We've done extensive work on leach testing on road materials, both road-based material and wearing course material, to prove that even at prolonged times, at up to 60 degrees centigrade, water soaking the material, we still don't have any leaching. So when we were able to utilize not only contaminated biochars, but also contaminated feedstocks going through a low temperature, it's more towards torrefaction. We created demand, and starting with calculations on carbon sequestration, if you put 300 tons of biochar into 1 mile or 1 kilometer of road, it becomes quite significant, and it really starts counting up the amount of carbon credits involved. On values, we obviously support circular economy. Obviously, with the weather going bonkers, we need to do something about climate warming. And in the end, I think our biggest success was the ability to even use partially pyrolyzed material, partially carbonized material as well. And the emulsion systems helps to make it inert and lock it down underneath the surface. So we're essentially mimicking what Mother Nature is doing when she takes a tree and she puts it deep down and turns it into coal. Quick mention on the photos here. This is a combination of harvest waste and heavy-duty tarpaulins of various grades. and types, from LDPEs all the way through to high density polyurethanes, etc. And on top, the top photo is our first little pyrolysis unit, and all the black heaps in front there is construction char. So that's char made with co-pyrolizing various types of material. We use the term construction char. What is construction char? Construction char is a char or a biochar or a carbon black or a black carbon, anything with a carbon content more than 30%. We can get away. We can use material with carbon contents as low as 30%. And we deem that as construction char. That obviously also includes the high level or high grade agricultural chars if we can't find any other chars. We can use most any types. The top photo there is a collection of different biochars that was made from wood, straws, grasses, energy crops, biosolids out of the sewage industry, recycled activated carbons out of the mining industry. We basically, with the emulsion systems, we make sure we get the necessary covalent carbon bonds, which is stronger than the standard ionic bonds, and we make it inert, lock it down with near permanence. The next step then, what we did is we started pre-treating. The interim was blending different biochars for specific applications. The next step then was we started pre-treating feedstocks to already, during the pyrogenic or during the pyrolysis process, we start forming additional types of bonding mechanisms and aggregate replacing material. We then started using, we started adding biochar and our emulsions to concrete wastes, reclaimed concretes, reclaimed wrap, reclaimed asphalt products. And we also learned, the bottom picture here is a combination of different Marshall core sample blocks that was made with very bad soil types, wrap, ferrocretes. It gives us a natural red material, which is good for bus lanes. It stands out differently from the standard black asphalts. And then also we call them pindan soils. So it's micronized. It's like talcum powder. It's all the outback roads that the roads get pummeled into dust, very fine dust, and we were able to even make a material out of that, which then led to the ability to build roads in the middle of nowhere, utilizing local soils and gravels, not needing any quarry aggregates. So emission avoidance related to blasting, crushing, screening of quarries to get the necessary aggregates that is used in the conventional road systems. We don't need that. We replaced the use of Portland cement. The emulsion and biochar combinations give us a much better bonding mechanism. We don't use any heat. It's a cold process, cold product. We don't need any solvents because it's an anionic product. It's not a cationic product. So there's a lot more information available that I can provide on further request. So what is the benefits? Traditionally, for a long time, there's thousands of white paper studies and university studies of the advantage of putting biochar into construction media, including hot asphalt systems. Their biggest drawback was always been they can only do it at very, very small quantities, 2 or 3% of total mass, or in some cases 2 or 3% of total Portland cement content in the concrete. We jumped straight up to initially 5%, then up to 10, then up to 15, and we have done successful material with as high as 25% biochar content, but we cannot do that consistently yet. Up to 15% we can do consistently. This little video playing here is material that's installed in access roads to wine farms. We've done all the, it's safe for use in the agricultural industry. Obviously, it's a low cost material, because material, in many cases, you get paid to take feedstock if it's contaminated organics out of river systems, if it's PFAS contaminated wood products or wood waste out of the forest industry, previously burned forests, etc. We can utilize all of that. The next, there's some slides coming to show how we manufacture it. On the performance side, we've done extensive combination and test work against most or all of the other types of conventional road systems, and we are in many cases 3 to 5 times better in performance and stability. The material is so strong that if we put a 30mm overlay of the cold premix onto an airport runway, the big birds can come and sit down and we don't get any shearing. So there's a long list of the advantages in performance. This is our favorite little homemade video. We started the slogan saying that with these massive amounts of biochar that we can get into roads, road base, both the wearing course and the road base application, it will be the handbrake on climate warming. Calculations are massive. One example is we did a quarry access road in Thailand, and it was supposed to be a 30mm thick installation because it's heavy duty. Our maximum thickness that we apply normally is 30mm in the wearing course. We used carbon black from the tire pyrolysis industry as the carbon source for this specific road, and installed it in the middle of the night with hand rollers. Because the equipment promised, it never arrived, and 6 months later we started doing core drilling, and we were shocked to find that the road, and we drilled many different places in the road, the maximum thickness that we found anywhere in the road was 12mm, half an inch, and there was no cracking, creeping, leaching. One thing to note is we do not need tack coats or binder coats or spray coats. We can install directly onto a damp compacted laterite road. Top right is combinations of reclaimed sealing boards, crushed sealing boards, brick waste, waste from the brick making industry, and of course biochar. There's always biochar that goes in with it. These are very bad high clay content soils. Normally we need to put a little bit of limestone powder in there just to stabilize it a bit, but with the extra biochar loads in there, we get very good surfaces. The process, very straightforward actually. The first step is to make emulsion. And that's a containerized type emulsion plant. We utilize the same bitumen as what is used for the conventional hot mix asphalt industry. We just receive the bitumen at heat. We don't heat it any further. We turn it immediately into a cold anionic emulsion. With this equipment, it's a fairly straightforward process, no solvents required. And then we can store the emulsion for up to a year in tanks. A long shelf life. Again, no heat or solvents needed to keep it at the same viscosity as water. Obviously, biochar can come from many different directions, many different types. We are currently working on technology to speed up the partial pyrolysis of all kinds of combination feedstocks. Because we can handle or utilize partially pyrolyzed stuff, you can start with much higher moisture content. So it doesn't matter if it doesn't come out fully pyrolyzed. So that there's a lot of advantages in scaling up the volume of biochar production. So the emulsion is stored in tanks. If we do very high level or high duty wearing coarse materials, we do use some controlled aggregates from quarries. The biochar plus the quarry material goes into a planetary paddle mixer. Dry mix for about 20 seconds, then add roughly 10% emulsion, and wet mix for 20 seconds, and the material that comes out can either go into 1-ton bulker bags with a shelf life of a year. We ship cold mix products from Malaysia to 14 countries in the world, and install permanent roads in the middle of nowhere. Or if the material is put onto the back of tipper lorries, and this material contains up to 15% biochar, then the tip lorry life of this material is up to 2 to 3 weeks, depending on weather conditions, which means you can drive for 2 weeks and then go and install a brand new high-duty road in the middle of nowhere, not needing any heat or solvents. This is a little video of one of our production plants. That's the cold premix coming out after it's mixed. You touch it, it's not sticky, it's no solvents, there's no heat involved, obviously. And that's samples that's taken for quality control. Just a few examples. We did a thin overlay, 20mm overlay inside a truck yard. So this is one of the big trucking yards, and this specific space here was in very bad condition because that's where the trucks do the U-turns, and the side shearing obviously causes a lot of damage. This was actually the compaction of that area. We only need lightweight compaction equipment. We don't need the heavy stuff. Installation is much quicker. Utilizing a standard paving machine, heat switch off, no solvents needed. The cold premix goes through the standard paving machines. With the advantage, the machines can actually move much faster because the stuff is not sticky, so it doesn't shear. So we, with one team, one paving machine, and one compactor, we can install up to 3 to 4 kilometers of road in one day, which is 4 times more than what you can do with conventional hot asphalt. Finger problems. A quick note on financing and demand. It's always been extremely difficult to obtain the necessary financing to scale up or ramp up the cold premix operations that we started in Africa and in Asia. And dare I say, one of the biggest hurdles or stumbling blocks was the political pressure that we get from hot mix asphalt guys. And the reason for that is per square meter installed, our products are up to 30% cheaper per square meter installed, or per square yard if it's America. And that obviously we're seen as a threat, and there were a lot of hurdles. Up until 5 years ago, we, however, utilized coal fines as the carbon source for our products. All of that changed 5.5 years ago when we switched over from using coal fines. We switched over to biochar, and obviously with climate and climate credits, and it gave us a bump where people now want to work with us and not try and shut us down for financial reasons. So lately, we have obtained numerous high-level finance application or finance systems already. We later this year we will launch with a 500-ton plus product quantity into North America. We can provide some details, and happy to see you guys there when we start doing that. We will also launch into East Malaysia. We have substantial funding in place now to scale up our biochar production facilities. We currently produce about 12,000 ton of biochar a year in East Malaysia. That's going to increase to 100,000 ton of biochar, construction char, specifically or predominantly construction char. So support is driven, financing is driven by the current world climate support systems. We just need to find the right partners to work with, and everything that we can into a construction char while the rest of the world gets themselves sorted out on how to do the agricultural chars and feedstock chars, animal feedstock chars at scale. We are ready to go to scale. Just a few slides on Cameroon. This is access roads to mines. This one was about, I think about 85, 87 kilometers long. Installed in 2007, I think, and it's still there today. Because of the fact that our roads are waterproof, biochar is naturally anti-wetting. Biochar conducts heat, so the road surfaces are a lot cooler. We don't get cracking and creeping, and we have a penetration bond into the road base. It's not a layer of glue in the form of a tack coat or a spray coat. Our roads tend to last a lot longer, and it also protects the road base, which is actually doing the work, which makes for a much longer living road. This one here, we've done thousands of tons of material as military roads in East Malaysia. The military loves working with the products because it's easy to install. They can do it themselves. This is heavy duty factory floor installations for a major big group. It's called Cargill. It's one of the biggest palm and sugarcane industries in the world. Myanmar, before things went a little bit upside down there lately with the politics, but we've installed many roads in Myanmar. Material was shipped from Malaysia. Vietnam, we have two. There's a third major big production plant going up there now. We have one in Hanoi and one in Saigon, Ho Chi Minh, producing. That material is used for small streets, large streets, motorways. We've done a section of the new motorway upgrade between Ho Chi Minh and Hanoi. Community centers, paddy field roads, so in all amongst the rice paddies, all the roads get sealed with this. India, at some stage we don't have a production plant there yet, but we at some stage we were exporting about 500,000 bags a year to India for installation. Timor-Leste, we've done many, I think must be more than 90 kilometers of coastal roads. And the beauty of the system is you can install half the road. People can walk across it. You don't disrupt the community. You install half the road, compact it, and open it for traffic. Within 20 minutes, you can open it for traffic. And then you do the other half of the road. So if there's only single road access to areas, then you don't disrupt the traffic. Madagascar, obviously Africa, we've done a lot. This is just some sample pictures. Australia, obviously we've done a lot, including all roads for mines, but we have already signed away the utilization, the licensed technologies to utilize the technology in Australia. So the world is available. Australia and New Zealand is locked out already. And currently we're continuing sample testing different types of materials, different contamination levels, and obviously working towards very dedicated construction chars in general. This slide, this is, I think, information that's available from many different sectors, but this speaks for itself. If we can just replace conventional high CO2 footprint material in the construction industry, then we already take away 25% of the headaches in the world. And if we work together, it is doable because we can scale it up. We've done some little race courses as well, so we're racing forward into the future to make the world a better place. And I thank you for the opportunity. It's not easy to keep the presentation short. Happy to take questions now or later. Not sure when enable slideshow.
Hello.
Yeah. Now I need to
just get